Hello everyone, so today in this video we are going to solve a question of LeetCode that is out of boundary paths. This is 576th question of LeetCode and this comes under medium category. Alright, so let's start with the problem statement. There is an M into N grid with a ball. The ball is initially positioned at the position start row and start column, right? This is the initial position of the ball. You are allowed to move the ball to one of the four adjacent cells in the grid, right? So we have four possibilities. Either we can go to upward direction or downward direction or the right or the left, right? These are the four possibilities. Now you can apply at most, right? At most max move, right? So at most we have given, it means we can take any number of moves in this range, right? And given the five integers m and max move, start row, start column, we need to return the number of path to move the ball out of the grid, right? So we need to basically find out the number of possibilities in which we are just going out of this grid, right? And the answer can be very large, so we need to return it into the module, right? So we will just take the modulus of the answer in each step. Right, so let's quickly understand the question with the first example. So in the first example, we have m equal to 2, right? We have m equal to 2, then we have n equal to 2, right? Then we have max move, right? This is, let's write mm is equal to 2, and we have the starting coordinate is 0 comma 0, right? This is the initial position of the ball, right? So let's first make this grid. This is a 2 into 2 grid. So let's make this grid. So if we make this grid, it will become something like this, and this grid will be having two rows, right? This will be having two rows and two columns, right? So initially, right, initially the ball is at 0 comma 0. So let's place the ball here, right? This is the 0 comma 0. So let's place the ball here and let's find out all the possibilities. So let's try to find out all the possibilities. So in this, the at most moves, right? The at most move or the maximum move we can take is equal to 2. So let's start with the first move, right? Initially we are at this, so it means we have taken 0 moves here. So let's start with the first move. Let's say we take a first move. So if we take a first move, so we will go either upward direction, or we can go to right direction, or we can go to downward direction, or we can go to left direction. These are the four possibilities, right? So if we go to the upward direction, we will go out of this grid, right? So this is the possible answer. Then we can go, like if we go leftward direction, then again we are going to out of the grid. This is also possible answer. And other two directions are not possible, or we can say we can take this move but it is not going out of the grid, so we don't need to consider this, right? So now let's take the second move, and this is the last move we can take because at most moves we can take is equal to 2. So now we are at here, one ball is here, or other possibility it could be here. So if we move upward from here, we are going out of this. If we move right from this, we are going out of this. If we go count downwards, no, this is not the possible answer. Now if we go to backward, this is also not possible. So in this case, if we move this ball, right, if we move this ball, because in the first step we moved this ball to here, so for this the second step are the four possibilities shown here. So in this we are going out of the grid in this and in this, right? So two possibilities are coming from here. Now let's see for this. For this we are going out of grid, for this we are going out of grid, for this, and other possibilities won't work here, right? So these are the two more possibilities. So what we can conclude here is that we have taken two moves, right? We have taken two moves and we have found out all the possibilities. So what is the maximum count, right? So let's count the possibilities. This is first, this is second, this is the third one, this is the fourth one, this is the fifth one, and this is the sixth one. So total we got six possibilities. So we will be returning six in this case, right? This is the output is 6. So this is basically we are just checking all the possibilities, right? So let's say we start with a recursive step, right? So the brute force approach to solve this question is through recursion. So in the recursion, what we will do, we will check all the possibilities. So let's say What are all those possibilities? Let me just write it here. Let's say we have a cell here, right? Let's say this is a cell and the initial coordinates are I comma j, right? These are the initial coordinates. And what are the neighboring ones, right? What are those four possibilities? So we have a right cell here, right? We have a right cell here, we have a left cell here, right? Then we have a upper cell here and we have downward cell here. So these are the four possibilities or the four moves it can take in a single move, right? So let's see what are the updated coordinates. So in this, if we move to the rightward direction, the column will be changed but the row will remain same. So the row will be remain same as it is I, and the column will be updated to j plus 1, right? Similarly for the left one, the column will be decremented, so j minus 1, right? Then for the upward direction, row will be decremented, so I minus 1 and j, right? Similarly for downward direction, this will be I plus 1 and j, right? So these are the four possibilities it can take. So what we will do, we will just call a recursive function for all these four possibilities, and if in any of the possibilities it is going out of the grid, so we will just return one, right? We will just return one because we are considering each possibilities as one count, right? So we will be returning one in each case, right? So let's quickly code the brute force approach, then we will just update the solution and try to optimize this with the memorization in the DB. So let's quickly first code it up, the brute force solution. So in the brute force solution, what we will do, we will first take, let's say we start with, what we can do is, let's say we make a function here int sol. In this int sol, we are taking int m, int n, and int n is basically taking the maximum moves, right? And let's take int I and int j, these are the initial coordinates. And let's call this function from here. So sol, let's return it from here. So sol, let's pass m n max move, start row and start column, right? And in this int solve function, we will first check if this is going out of this bond, right? If this is going out of the grid, so in that case what we can do is, let's say in this case when it is going out of this bond, so what are those possibilities, right? So let me just write it here. The possibilities are, if, right, if I is less than 0, right? If I is less than 0, or j is less than 0, right? If I is less than 0 or j is less than 0, or I is greater than equal to m, right? M is basically the number of rows, and if j is greater than equal to n, n is basically the number of columns. So these are the four possibilities in which we will be getting our one possible answer. So let's write the similar condition here, right? So if I is less than 0, or j is less than 0, or I is greater than equal to m, or j is greater than equal to n, right? These are the four possibilities. If it is going out of the grid, then we will just return 1, right? We will just return 1 because in this case we are getting a possible answer, and in the each possible answer we are counting that possibilities as 1, right? And what are the all other conditions, right? In the other condition, what we can say is, in the other condition, let's say if this number of moves, right? Initially we have two moves, but when we will get out of the move, right? When the remaining moves equal to 2, it means we cannot take any more move, right? So we will just stop this function here. So for this we will be returning 0, right? So let me write the same condition here. If n is equal to 0, if this becomes 0, like the maximum moves become 0, it means we cannot take any move, so we will be returning 0 from here, right? Now let's call all the recursive function here. So in the recursive function we will just return, right, we will just return solve mn, right. This n will be decremented because we are just using a move here, so this move will be decremented, and I plus 1 and j, right. These are the possibilities we just discussed here, right. These are the possibilities we discussed here, right. These are the possibilities. So let's write all these possibilities. So let me just copy it here and we will just update for each value. So these are the four possibilities. This is I plus 1, let's make it I minus 1, right. This will be I and j plus 1, right, and this will become I and j minus 1, right. Let's try to run this. This is a brute force approach, so it might work for some cases but it won't work for all the cases. Let's try to run this for the base case. Yeah, it's working fine in this, but it won't work for higher cases, right, in the higher values. So let's try to optimize this. So whenever we optimize a DP problem, what we do, we just convert those recursive functions and we add a memorization table so that we reduce some steps, right. So what we do in recursive in the memorization, so we make a table, right, we make a table. So before that, let's first take this modulo, because we need to take this because the answer may go very large and it will give TLE and memory out of limit. So let's take this int mod is equal to 1e9 plus 7. This is the value of modulo given to us. Let's make it here and also take a grid for memorization in the DP. So let's make a int dp and the limit would be m is going till 50. Let's make the grid of 51, right. So in this, the first index is storing the I value, right. This will be storing the track of I value. Second will be storing the track of j value, and in this we are also keeping the track of n, right. We are also keeping the track of n because we need to change our answer according to the number of moves in the each example. So what we can do is we can take one more here, right. So let's take one more. Let it be a 3D DB question. So we are taking a 3D array, right. And in this, what we can do is let's first initialize all the values with -1. So mean set dp -1 and size of dp, right. We have just initialized all the value with -1, and in this, what we need to update, right, what we need to update is this statements are fine. We just need to add one condition here. If dp of I, j and n, right, these are the three indexes. So if I, j and n does not equal to -1, if it is does not equal to -1, it means we have already calculated that value earlier. So we don't need to run the recursive call again for this. So let's return the same from here. So dp I, j and n, right. Now let's store this here. So let's store this in dp, like the return answer will be stored in dp. So dp I, j and n, right. And let's take the modulus for each value. So the modulus would be, let's take the modulus for this, and let's take the modulus for this, and also take the modulus for the second sum, because whenever we are doing the addition or the sum, so in that the answer may go out of the bond, right, out of this modulo. So we need to keep this in this limit. So we will just take the modulo. So for this addition we have taken the modulo, for this part also take a modulo, and then we will take the modulo for the whole part, right. So for this also take a modulo, right, and for the outer part let's take a modulo, because in the each addition we are just taking the modulo to limit this, right. So this is fine. We have just changed few statement to memorize the solution, and let's try to run this again, right. This is the optimized solution. Oops, we are getting it. Yeah, we did a spelling mistake here. Yeah, it's working fine. Let's submit this. Yeah, it's working fine. So let's talk about the time and space complexity of this solution. So the time and space complexity of this solution, let's just discuss the time and complexity of the previous solution which we discussed of the recursive call, right? So the time complexity of the previous solution which we discussed few minutes back. So the time complexity of recursive solution without DP, right? Without DP. So for that, the time complexity was around big O of 4 to the power n, right? This was the time complexity of recursive call. But for this DP solution, right? For this DP with memoization, we just optimize the solution to time complexity of big O of m into n m into n into n, right? This is the updated time complexity of this solution. And the space complexity, right? The space complexity for this would be, the space complexity will also be the same, because we are just storing all these elements into this dp array. But for the previous solution, the space complexity was big O of n, but the time complexity was very high, that was 4 to the power n, right? So these are time and space complexity of both the solution which we discussed in this video. I hope the approach and solution is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. I will see you in the next video.